Hey, welcome back to Fully Defined. Build and Learn is a series where Lego builds and SolidWorks skills come together. And in this lesson, I'm focused on one part, and that is the vehicle exhaust pipe and the Technic pin. This is one of the more complicated models in this assembly that we've created. In saying that, it's just a basic bunch of simple geometry stacked up one on top of the other. Building this part, we're using sweep features, cut extrudes, loss extrudes, and finally Revolve to create all the details you can see on that part. Let's get started. Next, we have a very cool part, 28. Light bluish grey vehicle exhaust pipe with Technic pin flat end with square pinhole. Jeez, what a name for the part. There's some differences between them. No 3D preview. Large image. Cool. All right, so this is a completely unique part. Not one that has really any links to in the existing Lego parts we've done. So it's going to be a fresh model, right from scratch. Let's get into it. Create a new part, and we need to set and work out our origin. Now for this, we might do a sketch profile that goes the whole way. Let's set this bottom point here as our origin. Okay, we need to do a sketch profile that goes all the way around it. So let's set this opening here as our origin and put that on the right plane, and we'll just draw that up. We'll put a fillet in to start and then draw that all the way to the right. Now we're measuring this kind of object, and with the sketch that we've done on screen, we actually want to go with our approximate center line. Now we can work that out in two ways. One, we can measure the diameter of this, which is about 4.5. Let's say it's 4.6. to round off, so 2 by 3 minus, well, that minus this full length, excluding that little section there that's a bit flat. So that's a bit annoying. Maybe we won't do it that way unless we want to measure that one. That's not symmetrical. Let's go back to the original plan. So what we'll do is measure an approximate from the middle of that to our end point. We're very close to 50. So that's 50.8 from here to our end point, and then our height, center to bottom 12. The radius we're looking for is where the straight turns, so 5 mil radius. Okay, now we'll use this as some construction points. So we'll actually measure to the end point of the line as well. So this section here is about 9.2. What we'll do is we'll just put a sketch point there, 9.2, and then we can measure this section. That is 28.8. We'll put another sketch point in. And those sketch points are going to help us know exactly where our flats are. You follow, there's a line here, another, you can do an inside dimension, 92. Now, I'm not sure where it's going to sit. It does sit outside that curve, so I just dropped it in line, but not actually on the line. This will do. All right, cool. Now, let's start building. So the main section that goes through the middle, solid, has a diameter of 3.2. That's this section here. We can do another sketch, just convert this one and change this to a swept boss base for a circular profile, and that'll just give us an extrude on that section. Not an extrude, but a sweep. And because it's circular, it's very easy to do that nice and quick. The largest section we'll do with a revolve. We'll do that a little bit later. I want to get the end point done first. Now that end section we can do on our top plane. There is a circle there. We'll do the slot afterwards. So we have a circle, 4.8, and let's assume it's solid. What we will do here is another sketch convert. We'll take these two, and what we'll do is the same thing we did the first time around, turns that to a circular profile, and go 4.8. So we're not actually using this sketch we just created. We'll remove it and come back to that later. We do need to back off this face. So I'm going to do a convert. I'm going to select that edge as well. So I'm going to go extrude cut up to vertex. So just go thin out this one a little bit. You can see I do have to increase the size of the outside. This one on the outside, I'm going to offset that. This should be enough. There we go. So it kind of cuts at a weird angle. You can see it here. That's enough. That's okay for us. Now, the slot on the bottom, how it works is this part is kind of hollow. It has a wall thickness, about 1 millimeter. We will offset, reverse, 1 millimeter. And we're going to do an extruded cut up to this point. Now let's do our slot. A very small slot, 0.8 of a millimeter. We can do it on the front plane because this slot actually has a round to it. By that, I mean that the top of it is round, as you can see in this one. The height of the slot, 3 millimeters. And that is to highest point through all those. Okay. And then there's a very tiny lip, okay, on the very end of this part. You can see there's a little lip there that helps it click in to other features. Now, too small to measure, but we can see the diameter is a little bit bigger. Okay. And if we measure here, we get a diameter of 5. So for this feature, what I'm going to do is convert these two edges. We're going to do an extrude thin feature blind. I'm going to say 0.5 of a millimeter. We'll go this direction. The distance out is at 0.2. Let's just check this. I said it was going to be 5, so no, not even that. It's 0.1 out. It is tiny, but it's visible. Now these edges should be straight, so I'm just going to delete face, and that should straighten them up. Yep. And then there's a very small fillet on each of these edges at the bottom of the slot. So I select those for a fillet. Okay. Now what other details are on this? We have a bit of a rib on the face up the top here. How we're going to do that is just come back before any of this detail to a convert entities. We can measure the width as that detail, 4 millimeters. Then we can see it's about 0.5 millimeter offset. We are half. You're going to draw a line here, mirror that one, dimension in, trim, and then extrude. Now the position of this is 7 millimeters from the bottom, and it goes up a millimeter. So offset 7, you blind 1, flip the direction of both. Now it's going to merge result. You can see there's actually a bit of opening there. So maybe we can just delete face and that will remove it. No, the better thing to do is offset our sketch. This edge, which was on edge, just delete that, bring that in, change this dimension again to get those two concentric. All right, so here you can kind of see what we're getting at by just cheating a little bit, make that come into this inside 0.2. Now there's no gap there, and we just go back to merge result, and that'll merge it in. It's much better visual. Does have some small fillets again on these edges. We'll cook those in too. Nice. All right, and now let's roll that down. Now we can do that thicker section. This one we can do with a revolve and then a cut pattern. So what I'm talking about on this detail is you can see this thickness from one end to the other. It's round all the way. There is a hole on the bottom, which we cut afterwards. But otherwise, what we do here is we draw a center line through the middle. We draw the outside profile, and then we revolve the whole thing. We can, if we want to, put this sketch and pattern it into the original sketch, or we could do two features. We'll do a revolve and then a revolve cut. Let's just see what's easier as we go. Now, in our original sketch, we've got those points, so we know where it starts and finishes. So let's use that information, create a center line, and then ends of our revolve, just like that. Now we can measure the diameter. It's quite 8. It's going to be divided by 2. Okay, and that's our shape. Then our pattern does look like a cut. We can count the number of these and roughly dimension 1 and say it's 0.8. And then if I do a count, 15 of them. Do 15. I'll work on the spacing. We could estimate to about 1.8 apart. Now we can tweak that. We can work out where the first one is. It's about 3.4 millimeters from this edge. And then the last one, you see, at the moment, our spacing is way too big. So let's just delete that dimension. Instead, we'll bring this one back and dimension the last one. And it does actually look like a mirror 3.4. That makes it easy. So we dimension this one, 3.4. You can see the dimension of the pattern is worked out for us. The pattern dimension is actually 1.51. Okay. Now, we don't need to trim on this. We can just hit our revolve button. We do need to select the line to revolve around, which will be this. And then our contour, we're just going to select this open area and press OK. And that's done it for us. So very easy. We do have to add some fillets to get the rounds. Okay, so this is going to be a 0.4 mil radius. Now select one edge. Select all the edges like that. Just going to remove the outside ones. There we go. Maybe we need to increase that a little bit. 0.5, better. While we're here, we should save this. Got the name of our part. We just need to cut in the bottom. So top plane, just have a flip it over. We have a rectangle here that is 25.4 by 2. Now we can find the center point, put a center rectangle on that center point. We said 2 by 25.4. How deep does that cut go? I don't know if I can measure that. Close to 4 millimeters off the bottom edge of that. I think we just do a blind cut up, blind, up. So about here plus another 4 millimeters. So let's go 12.5. That looks pretty good. All right, nice work on that one. Let's bring it into the assembly. And where does it go? Straight through or connecting into that 3-hole. So this will be a concentric mate. I dare say this looks like it's going to hit this face. Okay, that fits nicely, just like the one at the front. Awesome. Nice work. All right, they do remain horizontal. So we will put a mate in to keep them parallel to the top plane. Press OK. Cancel. I don't know why that's an issue, that one. Should be straightforward. Top plane. Because the top, not the top plane of the part. That's why. Okay. Right plane of the part. Top plane of the assembly. Parallel. Duh. Okay, part 29. We have a red plate modified with a bar arm up. I think we can do this with one of these ones that was modified. Plate modified 1x2. Let's use this one. And if we're looking at our part, it is very similar. It's just got a bar going up instead of this one on the side. So what we will do is grab that name, save a copy. We will delete this bar, this mirror, and this boss extrude. The bar, when we look at it, we can see it is a consistent over matching what looks like to be the height of the plate, 3.2 millimeters. And so we will use the front plane, we will use the midpoint edge, and this now it says it's 5 millimeters up, and 5 millimeters is referring to, I don't know, but we can just measure the whole height of the part. We get about 9.4, right? And then for the width of the part, 13.5. Now, if that's going to be 3.2, we need to take off 1.6 from that. Now, we should put a very little radius in the bottom. It doesn't have much of a radius on it, but we need to get by, if we're doing a sweep, our sweep's going to be 1.2 circular profile, so 3.2. And you see it's not going to work with that radius so small, so that's actually a bit of a problem. We'll have to remove that radius, and instead we can do it a different way. In this method, we're going to do an extrude thin feature, mid-plane, 3.2. And we'll do the same here, 3.2. I'm going to unmerge, so I'll keep it merged, and then I'm going to grab my fillet tool and select the edges. I've got those 4 edges, and I've got these, not these 2 at the top, these 2 at the bottom. You can see it's got that swoosh going around the outside, so it's that one there. We'll just give it a small radius to that. Okay, and then that part is done, quick and easy. Let's bring it into the assembly, and where it goes, it's going to the top. Actually, it's going half off the back end. I find that issue in the assembly here because these should be at the same height. These ones are, let's have a look at them, 9.2, 9.6. I believe the standard is 9.6. So let's up the height of this one to match. There we go, and then we can update our mates on these. All correct, that aligns. Very good. Update the color and then mirror the part. Nice. Hey, thanks for watching all the way to the end. Really appreciate that. This has been the LEGO Build and Learn series by Fully Defined. If the next video has been released, it'll be on the top link to your right. Please hit the thumbs up and subscribe, and leave a comment below with what you'd like to see next. Your feedback is what motivates me to provide more content. See you in the next one.